Okay, class. So we are going to do this problem. It's just an integral. The way that we deal with integrals is just that we add an exponent to the variable. So let's just say that we have x squared in this case, right? So we have x squared. What we do is that we always add 1 to it. So in that case, it's just going to be x cubed. Okay. Now this one is actually 3x to the 0. Remember, anything raised to the 0 is just 1. And like I said, we have to add a 1 to it, so it just becomes 3x to the first. Also, if we add this 3, we need to do the reciprocal of this. Remember, this 3 is over 1, so reciprocal of 3 over 1 is just 1 over 3. Okay? Okay, so for the integral, just like I mentioned over here, the way that this will look like is the integral from -2 to 3 of x squared minus 3 dx, it will be x cubed, and reciprocal of this 3 is 1 over 3, minus 3x, and we're going to evaluate this from -2 to 3. Okay? This will always come over here, because those are the values that we're going to use in order to evaluate this integral. So then all we have to do now is just algebra. We just have to plug in this in here and in here, and then we do the same thing with plugging in this -2 in here and in here. I was always told that the calculus portion is 1 or 5% of the entire problem. Once you're done with the calculus, the rest is just pure algebra, which in this case we just did the calculus portion. Okay, calculus portion was just that right there. Now we just gotta deal with the algebra. So like I said, that's going to be 1 over 3, and this will be 3 raised to the 3 minus 3 times 3. Okay, let me put this in a bracket, minus 1 over 3. In this case, I'm gonna have -2 raised to the 3 minus 3 times -2. Okay, now I can easily cancel this 3 with one of these 3, but I'm just gonna keep it like that just because I want to have the common denominator. So 3 raised to the 3, okay, 3 raised to the 3 is 27. So I'm gonna end up with 27 over 3 minus 9. Now this one, it's over 1. Common denominator in this case is gonna be this 3, so I need to multiply top and bottom by 3. Okay, I'll come back to that one. So then that's gonna be minus -2 raised to the 3, that's -8 over 3 plus 6. -3 times -2 is 6. Again, common denominator, this over 1, it's 3. Multiply top and bottom by 3. So then what I end up over here is just going to be 27 over 3 minus 27 over 3. So this entire thing is just going to go to 0, cancels out. And I have -8 over 3 plus 18 over 3. Carry the negative. This negative is this one right there, because this entire thing went to 0. Okay, so then I have -8 plus 18, that's just positive 10 over 3. Don't forget to multiply that negative, and it's just -10 over 3 as your final answer. Okay, now let's try another example. In this case, I'm gonna have this one again, just add an exponent. So I'm gonna have 4. I'm gonna add 1 to the 3, which becomes 4, I do the reciprocal of this 4 over 1, which is 1/4, okay, times 1/4, minus 3, x squared. I'm going to add 1, so it just becomes 3. I have to do the reciprocal of this 3 over 1, which is just 1 over 3. And then I'm just going to do plus 2. I have to add 1 to that, so 1 plus 1 is 2, so it's going to be x raised to the second, and I have to do the reciprocal of this 2 over 1, which is 1 over 2, and this is all the way from 1 to 2. Again, this was over 1, that was over 1, and that was over 1, okay? That's where I got all of the reciprocals. Let me cancel things out. So 4 over 4 is just 1, so I end up with x to the 4th. 3 over 3 is just over 1, so I end up with x cubed. 2 over 2 is just 1, so I end up with x squared, and this all the way from 2 to 1. So again, with this problem, what I need to do, I just need to make a substitution of these 2 in here, in here, in here. And then I'm going to do the same thing with this one. I'm going to substitute it in here, in here, in here. And then I just have to subtract them. So that's going to be 2 raised to the 4th minus 2 raised to the 3 plus 2 raised to the 2. Okay, and actually I could have made this a lot easier by taking out x squared, because I can take out an x squared from there and then from there as well, but anyways, it doesn't matter. So then I'm just gonna put that as a bracket. I always like to put brackets just so that I can keep everything separated. So now when I put the 1 to the 4th minus 1 to the 3rd plus 1, okay, either way I know that 1 to the 4th is just 1. Okay, so then 2 to the 4th is 16 minus 8 plus 4 minus, that's 1 minus 1 plus 1. Okay, 1 to the 4th is 1. 1 to the 3rd is just 1. And then 1 to the 2nd is just 1. Alright? So just leave it, put parentheses so that you don't get confused. That's fine. So then I just take this. 16 minus 8 is 8. Okay. 8 plus 4 is 12. So 16 minus 8 is 8. And then 8 plus 4 is 12. Minus, this cancels out with that. End up with 1. Or 12 minus 1, which is just equal to 11. Okay. So these type of problems are actually quite simple. As a last problem, what I want to do, I want to work something out where you just make a use of. What does that mean is, it just has to do with the fact that sometimes you have integrals in which it's hard to integrate when you cannot distribute inside whatever you have. Like in this case, it will be hard to integrate this with that, right? So someone came over and decided, hey, you know what? why don't we make our lives easier and let's just make a u sub or a u substitution. So what that means is that you're going to let u equal to either x plus 1 or 2x plus x squared. Okay, in this case, I see that if I was to do 2x plus x squared, as my u sub, and I take the derivative. So the derivative of u is just going to be du. The derivative of all of this is just going to be 2 plus x squared, okay, dx. So then, what can we do in this case? X squared, oh no, I see, this is going to be 2x. Let me backtrack a little bit. I didn't take the derivative of this because this is derivative of 2x is just 2, okay, plus 2x dx. I can factor out a 2 from here. So what I'm trying to do is I'm trying to get this one, okay? So then du would equal to 2, 1 plus x dx. And I'm going to divide by 2 both sides, okay? Let me actually make this step just so that I don't confuse anyone. So I want to divide by 2 both sides. So if I do that, I end up with du over 2 is equal to 1 plus x vx. So now I can start making my entire substitution. So I have 1 plus x dx, which is 1 plus x dx. And I also have u, okay, being substituted with this entire thing of 2x plus x squared. So now what that looks like is that, like I said, x plus 1 dx, x plus 1 dx is just going to be this one right there. So then I'm going to, let's see, how can I do this without confusing anyone. So I'm just going to put it here. Even though it's not written as it's supposed to be, but I'm just going to put it. So du over 2, okay. Again, du over 2, it's replacing this entire thing. 1 plus x dx, 1 plus x dx. And u is going to replace this entire thing, which is this one. So that's just going to be square root of u, and we have the integral. Now, the reason I said that this is usually not written like that is because we tend to bring these 2 to the side, and we tend to put it on this side. So this is actually the integral of 1/2 square root of u du, okay? And the next step that actually I want to do is I want to bring this outside because it's just a constant, it's just a number. And I want to rewrite this one, so that is going to look like this. 1/2 integral of u 1/2 du, okay? Now I can take the derivative of this. So I'm gonna add 1 to this, right? I'm gonna add 1. So in this case, 1/2 plus 1, or 1 over 1, I need the common denominator, multiply by 2. So that's 1/2 plus 2 over 2, which is equal to 3 over 2, okay? And don't forget to also do the reciprocal of this. So that's going to be 1/2 integral, no, not integral anymore because that left. So I'm going to put a bracket, and that is going to be u raised to the 3 over 2, okay? And reciprocal of that is 2 over 3 plus c, okay? Where c is just any constant, okay? So then what happens is that this here cancel out, 2 over 2 cancel out, and I end up with 1 over 3 u 3 over 2 plus c. And then you can just go ahead and plug everything back in there. So that's gonna be 1 over 3 2x plus x squared plus c. And if I was grading, you could just leave it as that. Okay. Or you can distribute the 1/3 into the entire thing. Now, this, yeah, that should be fine. Oh, forgot this one, 3 over 2. Okay. And that is the final answer for that.